Hello, everyone. My name is Ivan Serbinovsky. I am team leader BIM team. And the purpose of my presentation today is to present you our BIM SDK. What is BIM SDK? Is the tool for building information modeling, and the main part of the BIM SDK currently is supporting work with RFA, RVT file formats, reading, visualize, saving, and so on. But we also starting work on IFC file format support. Current status of work with RVT RFA files is we publishing our rendering in visualizing in production state. Our saving has a beta state now, and we continue working on implementation, editing, and creation of elements for the files. The benefits from using BIM SDK is you can read RFA or RVT files, and after this you can draw it with Visualize SDK, or we can visualize it with our Visualize SDK. You also can draw them in browser with Cloud Product, which is a part of Visualize SDK. You also can publish it to 3D PDF or publish it in another file formats with Exchange tools. And also you can convert BREP data to the BREP data in another file format. This is also important for BIM because most part of geometry inside BIM files is BREP data. So let's start with file reading of the files. We implemented support of new file format 2019. Currently it's our base file format, and another file format should be converted to our base file format. Currently we can convert files started from 2015 file formats, and we can read RFA RVT files starting from 2011 formats. We also update in API of our classes according with the latest file formats, and this also was published for the latest update. Next part is visualization. As I already said, visualization has production state. So currently we can draw all elements with geometries. It's such elements like walls, roofs, floors, and so on. All of them contain geometry in element. It's BREP geometry. We can draw it. And these elements are using materials, lights, and also visual styles working with them. So on the screen you can see example of building. It's shaded mode, it's shaded visual style. For this visual style we are using color from the material, and also we are using fill pattern for the elements. You can see several walls with different fill patterns, and also the grass also using fill pattern. Another example is realistic mode. On the screen you can see a sheet with several with 4 different views. Right bottom view is a 3D view, and it has a realistic visual style. For realistic visual style from materials we are using textures and another color of material. So you can see result on the screen, and any file also contain a set of plane views. It's different floor plans, cell plans, elevation sections, and so on. So on the screen you can see 3 examples of different plans, and on these views also we are drawing annotation elements. These different elements, they doesn't contain any geometry inside. So for drawing such element we have to implement the drawing by data in the element, and on the screen you can see example of several sections, levels. So currently we also can draw them. And I want to show some couple complex examples. So on the screen you can see several high buildings with infrastructure around. It's an example of complex file which we successfully rendered. And let's continue with our latest visualization enhancement. So first of all is colors override. We implement this for latest release. We can override fill patterns or colors. It can be done by the element or by category. So on the screen you can see example of such override. This is a building, and several overrides was applied to the walls. First example, if the wall with green fill pattern, this fill pattern is different from another wall. So it's an example of override by the color and by the fill pattern for one element. Another example is with blue color. It has the same fill pattern like most another walls, and it has override for the element by the color. And also in this file we'll apply override by category the walls, and this override by fill pattern and by color, and you can see result on all another walls. So next enhancement is sections. As I already said, the file contains a set of different plans, sections, and so on. For these elements, we have to divide elements which must be visible and invisible. So we select it. But some of elements also must be cut by the plane. So this functionality also implemented. It's using Visual SDK possibility for this one. And the result you can see on the screen. The roof was cut and the walls and wall with window also was cut, and gaps was filled by cut fill pattern. So this is also special fill pattern in our material. And next enhancement which was done for the latest release is tessellation improvements. It was done in Visualize, but it's very important for BIM because most of our models using BREP. So on the screen you can see two pictures for the same objects, but the tessellation was created for different size of these objects. So on the left side you can see example of objects with tessellation for small size. The mesh not so smooth, but it has less number of triangle, less number of polygons, and this is enough for small objects, and it must be drawn fastly. But when we zoom the objects, we can regenerate mesh for the object, and you can see example on the right side. It has more smooth mesh, more number of triangles, and it looks better. It's important for objects which good visible on the screen. So next enhancement is visibility of elements. So we added possibility to turn off or turn on different elements in the model by category. So I would continue with writing support. It has beta status now, and for writing latest file format is also very important. We are saving only latest file format, so this means when we change our base file format, we will save only new file format. Currently we save 2019 file format. So for this also converting important, because if we can convert file to the latest, we can save it. Currently we have implementation for conversion starting from 2015, so you can open any file starting from this file format and save it to the latest. Next one is elements creation. So we currently have implementation for set of elements, and first of all is curve elements, for example. Curve elements in our database contain geometry for different curves like line, arc, elliptical arc, Hermite spline. So we can create it, add to database, and render. The example you can see on the left side of the screen. Next set of elements is different levels, 3D views, section plans. All of them are DB view based. We can create these elements, we can add it to the database and use it. We also can add to database custom parameters. We can add it to RFA model file, and also we can add it to family. We also can create connectors. Connectors are used in such areas like heating, ventilation, air conditioning, and the example you can see on right side of the screen. Currently, we also have possibility to create such elements. And another important part of elements is direct shape and freeform elements. They provided possibility for customers store their own geometry inside the file. For example, direct shape element can contain BREP geometry or mesh geometry or another geometry. This is not parametric geometry from the point of view of it, but it's important for storing some customer geometry. Some example you can see on the middle of the screen is direct shape, and also direct shape type is element which are using set of direct shape elements for sharing some general parts. So it's also can be shared geometry through the direct shape type in model file. So for the BIM SDK, also BREP builder very important because many of our elements contain BREP data inside, and our BREP data is different if try to compare it with AC Spatial, for example, or Parasolid. So we implemented BREP builder interface. It's a helper for converting some customer BREP representation or for example, AC Spatial BREP representation to our own BREP representation. So the customer should fill BREP builder by the phases, ages, their relations, and in the end, BREP builder must create it correct BREP data for the file format. This currently working for BIM. We actively use it for creating our internal BREP representation, and this also can be used for creating BREP data for direct shape, for example. So, and some enhancement which was added for the latest release. Currently, we work on implementation different forms for families, and at the moment we implemented possibility to create extrusion and revolution. Next part is different elements which are based on modeling operation which already implemented. So currently it's extrusion and revolution. So we added possibility to create basic wall. It can be line-based wall or arc-based wall. So we can, they are using extrusion inside. For them, we are also creating BREP data, which needs for the elements, and all additional data which must be added in the element. So we will add it into the database, and you can use it. We continue working on another element like floor and roof, and on such these elements which are using revolution and extrusion functionality inside. But when we implement another functionality, we will support them in full state. We also created fillet region, can create fillet region now. Fillet region in BIM is an analog of hatch in drawings. But from BIM point of view, this element also contain BREP inside and using material, using fill pattern from the material. So currently we also provide possibility to create this element. Next important part is parameters. We can create customer parameters, can edit on database, and also each element contains 4 different arrays with parameter, but this array is usually free, doesn't have any parameter. So, but built-in parameters are very important for using BIM elements. So such parameters must be implemented in our code. We collect them on the fly. So we edit method getListParams, which collect all possibility parameters for the element by whole hierarchy of the classes of this element, and it return all parameters which are available for this element. And for each of them, you can also get the value for this parameter by getParam method. Parameters can be stored in different areas of element. Also, it can be in referenced elements, and also we have calculated parameters. So currently it's like parameters like area, volume, perimeter. We implemented possibility. We implemented them, we calculate them and return the value for you. But for the implementation, we have to use a mesh of BREP geometry. For this needs, we implemented possibility to get mesh not for whole objects, but only for one face. For example, we're using this for our needs, but this functionality also available with API, and you can use it for your needs. Next part is import exports. We for export different to different formats like PDF, SVG, DVF. We are using our kernel functionality, but for supporting this, we have to implement different protocol extension. Currently, we implement them, and this export are working well. But one more export is Collada export. It's also using our kernel implementation. It's working generally for all product. And the file contains set of triangle for different elements. And for Collada, we also has the implementation of import in BIM file. So we can open the file. We will create a set of direct shape elements for different elements which we find inside the Collada file. And for all this geometry, we provide possibility to select how store it in direct shape elements. It can be mesh, or we can convert to BREP data. And our plans is, first of all, is implementation family import, because most of elements like different windows, different doors, and so on, this is the family inside the file format. Currently, we are working on implementation base family import functionality. We try to import families with one family type and without parameters. So this is provide us possibility to implement this procedure generally, but next step we will implement, we will extend this functionality for working with any families, but for another families with parameters, with several family types is very important possibility to recreate the geometry of elements inside. So because when you change family type or parameters, geometry must be recalculated. So for these points, we continue implementing forms elements like SweepBlend, SweepBlend, and this our current work. We also continue work on implementation different elements like floor, roofs, and Boolean operation between them. We're also going to implement multi-threading for visualization and reading BIM files. And we also are going to implement for support of IFC file format. We created some predict file which contains set of lines and arc, which we are using for creating wall. We will select them and create set start point and end point, and we'll create view. The file also contain material inside, which we will apply for these elements. We can create material also, but for simplification, such demonstration we created already for the file. So currently we create walls. We can change view for 3D, for example, and we will see result. So we see set of walls. We can change visual style for shaded mode, and for realistic mode we see result views rendering with material. So currently we are going to save it to file and try to open it in Revit and see how Revit will react on our files. Revit open the same view. Currently we will select also 3D view for the file, and we see the same picture. So we can also select different views, for example shaded mode and realistic, and we also can select an element. So Revit understands this is a basic wall, and because we created correctly internal infrastructure, different steps inside, he provides possibility to modify these elements. So this element also correct from the point of view of Revit. It's also important. And another elements which we are going to create, this extrusion and revolution elements. So we also creating some file for showing this possibility. Here we have one loop for extrusion and several loops for revolution. The file also contains set of materials for different elements. So first of all, we created extrusion, and we continue create revolution. We select loop, we select axis for rotation, start angle, end angle, and select material for this element. So one element was created, and several more examples of revolution elements. So we also select loop, select axis rotation, and all parameters which need for this element. And a couple more elements, and after this we will see a result in 3D view, for example, because we created in for 2D view. This is section works now also. Select an axis, start and angles, and material name. And currently we created some scene with several objects of revolution and extrusion. Currently we will change view for 3D. So we see a table with set of parts on the table. You see mesh for the objects on the table. It's not so good because the size was smaller. When we zoom out it, we can regenerate the mesh, and we see a result better after regeneration. So we also can change visual styles for this shaded mode, which are using material colors from the materials of these elements, and also which we can select realistic mode. A realistic mode are using texture for the table and for the desk from the material, and also plate has another color for realistic mode in the setting of material. Currently we will save file also and try to open it in Revit. So we save the file and open it. After open Revit, also open the same plane. We will change for 3D view and rotate the objects. We see the same scene like we see it on ODA application. And you see a set of objects. We can change visual style for shaded mode. And we see different colors for different elements. And for realistic, we see another colors for these elements and also material and textures for Revit. We also can select an element, for example, a table. Revit draw a set of grip points and provided possibility to modify this element. Is also mean we're creating all internal infrastructure of this element correctly. We create a set of steps and Revit provide possibility to modify it. So that's all.